Thank you very much, Ranisha. So my name is Maryanne Maine. As Ranisha mentioned, I'm working for the GIZ Project Development Program. I'm responsible for our activities in Kenya and Ghana, and also in the humanitarian component. So the Project Development Program is funded by the German Federal Ministry of Economic Affairs and Energy under the German Energy Solutions Initiative. The main objective is to promote sustainable energy solutions worldwide, as well as to contribute to greenhouse gas emission reductions, as well as climate change. GIZ in itself is a non-profit company owned by the German government, and it operates in over 120 different countries with expertise in various topics such as energy, climate change, health, and so on. The Project Development Program, PDP, in itself provides technical support not only to humanitarian agencies, but also to the commercial and industrial scale projects to explore renewable energies through support to prefeasibility assessments. We are currently present in 18 different countries. Sorry about that. I was trying to minimize my screen. We are present in 18 different countries, with the largest footprint being in Africa, but also additionally in Asia, as well as the Middle East. So why solar in humanitarian context? We realize, especially in the various countries that we are in, solar provides significant cost savings. In some of the countries, for example, the levelized cost of electricity for solar is around about 10 US dollar cents in comparison to costs for grids or generator, around about 15 US dollar cents or even 54 US dollar cents when you look at a generator. This is the cost per kilowatt hour. Additionally, there's also the aspect of energy security. The conventional energy sources such as coal and gas and oil, they're going to deplete for sure, but the sun will always be shining. So there's always an aspect of energy security from an off-taker perspective. And then there's also the aspect of risk mitigation from future fuel and grid fluctuations. We've seen in many countries the cost for grid electricity prices and also for fuel keep fluctuating in as high as sometimes 7.1% per annum. Additionally, for solar projects, there's much lower CO2 emissions. And also when you look at a humanitarian agency perspective, there are now available customized solutions that are scalable and modular and also mobile in case a humanitarian agency would want to close shop and move to another site. So this outlines the process of prefeasibility assessments that we currently conduct. The first stage is usually the data collection and energy needs assessment. In this stage, we essentially look at the site, whether the area is available, for example. We collect electricity bills, for example. We assess what is the current electricity situation on site. Secondly, there's the load measurement perspective where we have consultants installing meters. And in these meters, we are actually able to read what is the electricity consumption being consumed by the facility, not only read from the utility bills, but actually measuring from the meter. And the third aspect is the technical optimization, where we use technical optimization software, for example, Homer and so on. And with this, we are able to design what is the optimal system required for the site. And the fourth aspect is the economic analysis, where we try to show whether the case is actually has an economic advantage compared to the business case scenario or the baseline scenario. And what are the initial considerations that we engage or we encourage humanitarian agencies to check as during the prefeasibility assessment process? I'm going to go through these 7 points. And the first is spatial requirements and site ownership. One, is there any ground or roof space available? And if there is, what is the total area? Because this is going to be a key significant determinant whether solar PV can actually be implemented or not. In some cases also, some of the sites are not owned, but also leased or rented. And you might need to talk, for example, to the landlord or the owner of the facility. The next aspect is the current electricity supply situation. Is the current electricity supplied from the electricity grid, or is it supplied from the generator what is the price, what is the capacity of the generator. So these are the aspects we really check so that we're able to compare with the proposed scenario. And also what is the pattern of operation, both the daily consumption profile or the monthly consumption profile as well. In some situations, there's a mix. Maybe there's a humanitarian agency, but also there's a residential facility there. And in a residential case, the electricity consumption is usually in the morning or in the evenings, and the sun is usually shining during the day. So you might need to check, how does my daily consumption profile look like? And this will advise whether we incorporate storage solutions or only a solar PV solution by itself. The monthly consumption profile, in some cases, some agencies might close shop, for example, in December when it's holiday season, and this will also be a key determinant in the input of the technical optimization process. And what are the regulatory requirements in the various jurisdictions? For example, in some countries, we see that the policy called net metering is allowed. And in this case, you're able to inject electricity to the grid, and you can get compensated for the power that you inject to the grid. In some countries, there's also a cap on the solar PV system size. They can say, for example, you're not allowed to install a PV system greater than 50 kilowatt peak or so. And also you might need to check what are the licensing requirements. Is there any limitation on business models, for example? Are there permits? What is the processing time that I need to implement my project? And so on and so forth. And with regards to business model, there are two key business models that we've seen with the projects that we've undertaken. One is the engineering, procurement, and construction model, where a humanitarian agency is the owner of the solar plant, and they're the ones who enter into a contract with an EPC contractor, as well as an operation and maintenance contractor. And the humanitarian agency is essentially responsible for the solar project throughout the lifetime of the project. In the second scenario, there's a solar company, and the solar company essentially guarantees the agency that they're going to generate a certain amount of solar electricity throughout the lifetime of the project. And they're the ones who enter into a contract with the financier, with the EPC contractor, and the operation and maintenance contractor. So here, there's also the aspect of what is the motivation of entering or implementing a solar PV project. On the one hand, the motivation could be you want to reduce electricity costs. On the other hand, can be the motivation of I want to be completely renewable. I do not want grid or generator. So we can look at these two types of scenarios, an on-grid solar project or an off-grid solar project. There are many other different types of solar PV systems, for example, hybrid cases where you can also connect to the generator and the grid. But in an on-grid solution, for instance, it's only the solar project and the grid is there, for example, serving the consumption at night or in the morning when the sun is not shining. And then there's also the aspect of the off-grid solar, where when the sun is not there, there's a battery involved. In this aspect, you can see the red line. This essentially showcases the electricity consumption for the site from midnight until midnight. And the green line shows a solar project that is essentially designed to cater only for the load during the day, load meaning the electricity consumption. But there's also the green dotted line, which a solar project can be much bigger, but the excess electricity can be stored in batteries to serve the electricity consumption in the morning and in the evening. There are these two selected case examples with similar electricity demand. In the first case, there was a utility grid contribution of 96%. Utility means like the electricity supply from the grid, but then they also had a generator contribution of around 4%, and they were paying around about 0.12 euro per kilowatt hour. In the second case, the same electricity demand, but all the electricity demand was met by the generator. And in the first case, a proposed solution of 50 kilowatt peak was suggested. And in the second case, there was a proposed solution of 120 kilowatt peak together with a battery and a battery inverter. In this case, you can see the contribution of the solar PV plant was around about 33%. This is the first 50 kilowatt peak project. And for this one, the black lines indicate the electricity consumption. Unfortunately, most of the consumption was during the day and in the evenings, but electricity from the solar plant covered the load during the day. There was a bit of excess, so that means some of the electricity was curtailed, or yeah. And then there was the 120 kilowatt peak project with a battery, and in this case there was significant, much more significant renewable energy contribution to the electricity generation mix, which was about 62%. And this shows the excess electricity, the yellow line from the solar project, and then the black line shows the electricity consumption on site. But the red line, which comes into play in this project, shows the electricity consumption or electricity generation from the solar project being saved in the battery, and this is consumed when the load is, for example, in the morning or in the evening. And there was an economic analysis for this, and in as much as the second scenario, which was a bigger system, it was a significant capex investment, for example, it had a higher return. And this is because the major baseline situation was electricity consumption from the diesel generator. In the second scenario, for example, you see a payback period of around between 4 and 5 years. And in the first scenario, a payback period of around 6 years. So what comes in the life cycle of a solar project? There's a pre-feasibility assessment, which I've mentioned in my presentation, and then there's a contracting period, financing, permits and licenses, procurement, commissioning, operation and maintenance, and eventually decommissioning. And the project development program supports essentially in the first stage of pre-feasibility assessment. Thank you very much.